An interesting property in the special methods is the reflection point. Let's say that you wrote this class that has a less than. If you try to compare b1 less than b2, it will be true, that's okay. But if you try to compare b2 greater than b1, surprisingly it will not give an error. Why? Because Python might do what we call the reflection. Think of that. Less than is simply the reflection of greater than as following. A greater than b is same as b less than a. So if Python can swap the objects and do the opposite operator, then it could work well. This is what's happening actually behind the scene. Let's see another example. I have here the class myBear, which has an add function. The function here is checking if the object I'm passing is of type myBear or not. If it isn't, it's returning not implemented. And be careful. Remember, we learned about the not implemented error. There is also a not implemented constant. So be careful. I'm here returning the not implemented constant, not the not implemented error, which is another thing. So if add is receiving something that isn't myBear, I am going to return not implemented. Otherwise, I'm going to implement it. There is another class here called single value, which just has single value. Let's say I created object from B and object from S. And now I'm calling B plus S. So B is from myBear. So B is going to be self here. Plus is going to be add. And S is going to be the other. But other here is in myBear. So this function is going to return my not implemented. Python now would be puzzled that you asked it for something that isn't implemented. And it's actually is going to give you an error, type error that this isn't implemented. But consider the following. What if the other opposite class can support the operation for us? Let's see this code. The same code here for myBear, but now for the single value it has the following. It has something called R for reflection, R add. And it takes an object from myBear. It checks, is it myBear? If yes, we do something. Otherwise, again, to return not implemented. And you should implement it professionally this way. Check first what you are going to add. Now, if myBear is actually a myBear, then I'm going to add my value to its two items and returning myBear. Now let's see now the code at the moment. B plus S. B is self, plus is add, S is self. This is going to return not implemented. When you return not implemented, Python will try to reflect things. By that we means it's going to try S plus B, but this time it's going to call the R add in the second object. So now Python is going to reflect and so by reflection we mean it's going to swap them. So instead B plus S, it's going to be S plus B, and it's going to call the function named with the R add. Now let's say we have S plus B. So S is the self, B is my add, but we are calling R add. Is it myBear? Yes. Add the values and we are done. So observe here. Although B plus S is actually supposed to call this add, Python ended up interpreter calling the R add with the swapping things. This is why sometimes you notice that you didn't get an error. Let's see another scenario. Let's from the beginning try S plus B. Okay, so what's going to happen here? S is going to match the self. B is going to match myBear. But the plus would like to match the add. The add isn't overwritten here. So this is equivalent to like not implemented. Now the function is going to reflect. So it's going to call as if we're calling B plus S, but with the R add. When we go to the myBear, it doesn't have an R add. So again, not implemented. At this moment, it's going to give us a type error. So be careful. When you write something like S plus B, Python will search for the add function in the S and make sure that B is valid, like we didn't return not implemented. And after that, if it succeeds, that's okay. But if it failed, it's going to swap them and search for the R add in the other object. If it doesn't exist or return a not implemented error, it's going to fail. So be careful, because sometimes this is very confusing, like you don't understand what happened behind the scene. The reflection exists in the other operators. So if you would like to subtract mod bow, it's also available. In the reflection, it doesn't search for something with the R. It searches for the opposite. So if you try to do less than, the reflection will search for greater than search for less than search for less than or equal, search for greater than or equal, and equal is searching for the not equal. So these are the reflection that's happening behind the scene. It's important to understand to not make mistakes from the code. That's all.